Section 1. Before save versus after save flows. Here's the question. When do you use a before save flow versus an after save flow? Before save flows are used when you want to update fields on the same record. Things like scoring, status updates, calculations. They run fast. They are efficient. They don't use database operations. That's why they are preferred. After save flows are used when you need to affect other records or external systems. For example, creating tasks, sending emails, assigning owners, calling APIs. These require database rights, so they run after the record is saved. Remember it like this. Update this record equals before save. Do extra actions equals after save. Section 2. Safely updating large volumes of data. Next question. What's the safest way to update 50,000 records in Salesforce? First, you export the data. Always, you never work blind. Second, you clean it in Excel. Remove errors, fix formats, check duplicates. Third, you use data loader with Upsert, not manual editing. Fourth, you run it in batches. You test on a small sample first, always. And finally, you review the error files. Every time. One rule, never mass edit huge volumes directly in production. That's how disasters happen. Section 3. Debugging failing flows. Next question. A flow keeps failing randomly. What's the first thing you check? You check the logs, always. Start with flow error emails, paused interviews, debug logs, fault paths, Salesforce logs, almost everything. If something is failing, there is a record of it somewhere. Failures are rarely random. They are usually just undocumented. Section 4. Preventing duplicate leads. Next question. How do you prevent duplicate leads? You work at multiple levels. Matching rules, duplicate rules, validation rules, standardized formats. But most importantly, you fix the source. Duplicates usually start outside Salesforce. Bad forms, messy imports, third-party tools. If you don't fix that, you'll always be cleaning later. Section 5. Understanding Upsert. Next question. When do you use Upsert instead of update and data loader? You use update when you already have Salesforce record IDs. You use Upsert when you're matching on something else, like email, external ID customer number. Upsert means if it exists, update it. If it doesn't, create it automatically. That's why Upsert prevents duplicates. It's controlled automation. Section 6. Why Upsert matters. Here's why interviewers care. Upsert shows that you understand data safety, scale, integration thinking, best practice. Blind inserts create chaos. Blind updates fail. Upsert is professional. Section 7. First memory lock-in. Let's lock this in. Before save equals fast field updates. After save equals actions and integrations. Large updates equals export, clean, test, batch. Flow errors equal logs and fault paths. Duplicates start at the source. Upsert equals smart saving. Closing. Episode 1. You've just covered automation logic, data safety, debugging, deduplication, Upsert strategy. This is core admin knowledge. If you explain these calmly, interviewers trust you. In the next episode, we'll go deeper into external IDs and integration foundations. That's where admins start sounding senior. This has been the Salesforce Admin Crash Course. Episode 1. Stay focused, stay consistent, and I'll see you in the next chapter. Episode 2. Integration Foundations. Hello, and welcome back to the Salesforce Admin Crash Course. This is Episode 2. Today, we're focusing on integration foundations. This is where admins start to sound senior and professional. Let's begin. Section 1. What are external IDs? Here's the question. What is an external ID in Salesforce? An external ID is a special field that stores an identifier from another system, not Salesforce's ID. Another system's ID, for example, a website user ID, a finance system customer number, or a marketing platform contact ID. Salesforce didn't create these, but you still need to track them, so you store them as external IDs. Section 2. Why external IDs matter. Why do external IDs exist? Because modern businesses use multiple systems. Website, CRM, finance, marketing, support. Each system has its own IDs. Without external IDs, you can't link data properly. You get duplicates, you get confusion, you lose trust. External IDs create alignment. They tell Salesforce, this record matches that system's record. Section 3. External IDs and Upsert. This is where it gets powerful. External IDs work with Upsert. When you Upsert, you choose a matching field. If that field is an external ID, Salesforce can match perfectly. Example. Website sends user ID 12345. Name Andrew email andrew@gmail.com. In Salesforce, website underscore ID underscore underscore C equals 12345, marked as external ID. When you Upsert, if 12345 exists, then update. If not, then create. No guessing. No duplicates. Clean data. Section 4. Why email is not enough. Many admins rely on email. That's risky. Emails change. People mistype. People use multiple accounts. External IDs are stable. They don't change. That's why professionals use them. Email is a backup. External ID is the foundation. Section 5. How to create an external ID. Here's the simple process. In Salesforce, create a custom field. Text or number. Tick external ID. Usually tick unique too. Save. That's it. Now Salesforce can match on it. That field becomes integration ready. Section 6. What are name credentials? Next question. What are name credentials? Name credentials are where Salesforce securely stores login details for external systems. They store URLs, usernames, passwords, tokens, OAuth settings, all in one place, securely. Instead of putting credentials in code or flows, you let Salesforce manage them. Section 7. Why name credentials exist before name credentials. People hard-coded passwords in Apex, in flows, in scripts. That's dangerous. If someone sees the code, they see the password. Security risk, compliance risk, career risk. Name credentials remove that. They centralize security. Section 8. How name credentials work. Think of it like a vault. Salesforce keeps a locked safe. Inside, login details, tokens, certificates. Your automation just says, use this credential. Salesforce handles the rest. You never touch the password again. Section 9. OAuth versus basic authentication. You'll hear these terms. Here's the simple version. Basic authentication is username and password. Old, less secure. OAuth uses secure tokens. Modern, industry standard, more secure. Name credentials support both, but OAuth is preferred. Section 10. Where you use name credentials. You use name credentials in Apex callouts, flows, external services, REST integrations, anywhere Salesforce talks to another system. If there's no name credential, it's usually bad practice. Section 11. Interview level answer. If they ask, what are name credentials? You say they're a secure way to store authentication details for external systems so credentials aren't hard-coded. That's perfect. If you want bonus points, they also support OAuth and simplify endpoint management. Senior answer. Section 12. Common integration mistakes. Here's what bad setups look like. Hard-coded passwords, shared accounts, no token rotation, credentials and text fields. All red flags. Good admins avoid this. Always. Section 13. Memory lock-in. Let's lock this in. External IDs connect Salesforce to other systems. They prevent duplicates. They power Upsert. Name credentials protect security. They store secrets safely. OAuth is modern. Basic auth is legacy. Email is unreliable. External IDs are stable. Closing. Episode 2. You've just covered external IDs, Upsert matching, integration identity, name credentials, security basics. This is integration thinking. Most admins never go this deep. You are. In the next episode, we'll tackle governor limits in performance design. That's where systems either scale or collapse. This has been the Salesforce Admin Crash Course, Episode 2. Stay sharp, stay consistent, and I'll see you in the next chapter. Episode 3, Governor Limits in Performance. Hello, and welcome back to the Salesforce Admin Crash Course. This is Episode 3. Today we're talking about governor limits in performance. This is one of the most important technical topics in Salesforce. It separates people who build systems that scale from people who build systems that break. Let's begin. Section 1. What are governor limits? Here's the question. What are governor limits? Governor limits are rules that control how much system power one user or one process can use. Salesforce is shared by millions of companies, so they limit resources to keep everything stable. Think of it like speed limits. Everyone gets to move. No one gets to block the road. Section 2. Why governor limits exist. Without limits, one bad automation could crash servers, slow everyone down, break entire systems. So Salesforce says, you can only use this much, and that's final. Section 3. The main limits you must know. You don't need to memorize everything, just these 4. First, SOQL query limits. This controls how many database searches you can run. If you query inside loops, you'll hit this fast. That's why people say, never query in loops. Second, DML limits. This controls how many records you can create, update, delete, or upsert. Too many writes equals failure, so you batch your updates. Third, CPU time limits. This controls how long your logic can run. If it takes too long, Salesforce stops it. Heavy processing must be optimized or moved to background jobs. Fourth, heap size limits. This is memory, how much data you can hold at once. Big lists, big files, big objects. Too much equals crash. Section 4. What happens when you hit? Limits. When limits are exceeded, everything stops. Users see errors. Flows fail. Sales complains. Trust disappears. So good admins design to avoid this. Section 5. Bulkification. Explain. This is the key concept. Bulkification. It means designing logic to handle many records at once, not one by one. Your automation should work the same for 1 record, 10 records, 100 records. Flows and Apex must be bulk safe, always. Section 6. Avoiding common mistakes. Here are the big mistakes. Querying inside loops, updating records one by one, running heavy logic in real time, building too many overlapping automations. These kill performance. Section 7. Smart design patterns. Here's what professionals do. They query once, then loop in memory. They update in batches. They use before-save flows when possible. They move heavy jobs to async processing. Batch, queuable, scheduled. They clean automation regularly, no bloat. Section 8. Real-world example. Imagine 500 leads come in at once. Bad design for each lead. Query account. Update lead. Send email. Hundreds of queries. Crash. Good design. Query once. Process in memory. Batch update. Smooth. Section 9. Interview level answers. If they ask, what are governor limits? You say, they're limits Salesforce uses to control resource usage like queries, updates, and CPU time. Perfect. If they ask, how do you avoid them? You say, by bulkifying logic, avoiding queries and loops, using before-save flows, and moving heavy processing to async jobs. Senior answer. Section 10. Memory lock-in. Let's lock this in. Limits control, queries, writes, time, memory. You avoid them with bulk design, efficient flows, async jobs, clean automation. Governor limits mean share nicely. Closing. Episode 3. You've just covered governor limits, bulkification, performance design, scalable automation. This knowledge prevents outages. It prevents late nights It protects your reputation. In the next episode, we'll focus on reports and SOQL optimization. That's how you turn slow organizations into fast ones. This has been the Salesforce Admin Crash Course. Episode 3. Stay disciplined, stay consistent, and I'll see you in the next chapter. Episode 4. Reports and SOQL optimization. Hello, and welcome back to the Salesforce Admin Crash Course. This is Episode 4. Today we're focusing on reports and SOQL optimization. This is how you fix slow dashboards, angry managers, and Salesforce is lagging complaints. Let's begin. Section 1. What is SOQL? Here's the question. What is SOQL? SOQL is Salesforce's database query language. It's how Salesforce asks, give me these records. Reports use it. Apex uses it. Flows use it. Dashboards use it. Under the hood, it's all SOQL. If SOQL is bad, everything is slow. Section 2. Why optimization matters. As orgs grow, so does data. More users, more records, more reports, more dashboards. If queries are inefficient, Salesforce scans too much data. That causes slowness, timeouts, limit errors. Optimization equals speed. Section 3. Non-selective queries. This is the biggest performance killer. A non-selective query scans most of the database. Example, give me all leads where country is not empty. That's almost everything. Slow. A selective query targets a small set. Example, give me hot leads created this month. Fast. That's the difference. Section 4. Index fields. Indexed fields are fast lanes. They help Salesforce find records quickly. Examples include record ID, created date, owner ID, external IDs, unique fields. Filtering on these improves speed. Filtering on random text slows everything down. Section 5. Report design basics. Bad reports usually have no date filters, too many joins, too many groupings, huge data sets. They pull everything. They time out. Good reports use date ranges, status filters, owner filters, indexed fields, fast, reliable. Section 6. Joined reports. Joined reports are powerful, but they're heavy. They combine multiple data sets. That costs performance. Use them only when necessary, not everywhere. Section 7. Dashboards depend on reports. Here's the secret. You don't optimize dashboards. You optimize reports. Slow reports equal slow dashboards. Fix the reports. Everything improves. Section 8. Practical optimization tips. Here's what professionals do. Always use date filters. Created date, close date, last modified date. Filter early. Don't pull everything and filter later. Use index fields. Reduce rows. Summarize. Group. Limit. Archive old data. Old data slows systems. Section 9. Real-world example. Sales complains, my dashboard takes 30 seconds. You check. No date filter. 5 years of data. You add this year only. Load time, 3 seconds. Problem solved. Hero status. Section 10. Interview level answers. If they ask, how do you optimize reports? You say, by using selective filters, index fields, date ranges, and avoiding heavy joins. Perfect. If they ask, what's a non-selective query? You say, one that scans most of the table and causes performance issues. Strong answer. Section 11. Memory lock-in. Let's lock this in. Bad performance comes from non-selective filters, no date ranges, heavy joins, huge datasets. Good performance comes from index fields, date filters, smart grouping, clean data, big net equals slow, small net equals fast. P closing. Episode 4. You've just covered SOQL basics, query selectivity, indexing, report design, dashboard performance. This is how you protect leadership's trust. Fast data builds confidence, slow data destroys it. In the next episode, we'll cover data movement and deployment. That's how changes move safely from sandbox to production. This has been the Salesforce Admin Crash Course. Episode 4, stay sharp, stay consistent, and I'll see you in the next chapter. Episode 5, data movement and deployment. Hello, and welcome back to the Salesforce Admin Crash Course. This is episode 5. Today we're focusing on how data moves in and out of Salesforce and how changes move safely between environments. This is about discipline. Good data movement and clean deployments protect your reputation. Let's begin. Section 1. Why data movement matters. Here's the question. Why does data movement matter? Because bad imports destroy trust. Wrong records, missing data, duplicates. Once users lose confidence, it's very hard to get back. So professionals move data carefully. Section 2. Import Wizard First Tool. The Import Wizard. This is Salesforce's built-in tool. No installation, simple interface. Use it for small data sets, a few thousand records, one-off jobs. Example, uploading leads from an event, perfect use case, not for big migrations. Section 3, Data Loader Second Tool. Data Loader. This is the workhorse. Use it for large volumes, 50,000 plus, migrations, complex updates, ongoing syncs. It supports insert, update, upsert, delete, export, and error tracking. This is what consultants use daily. Section 4, AP is third tool. APIs. APIs are for system-to-system communication. No human involvement. They run automatically. 24/7. Use APIs when websites send leads, apps sync data, finance systems integrate, AI tools connect, build once, run forever. Section 5. Choosing the right tool. Here's the rule. Small manual job, import wizard. Big manual job, data loader. Automatic sync. A PI, simple. Section 6. Best practices for imports. Always follow this process. Backup first, test on a small sample, validate your data, run in batches, review error files, document what you did, never skip steps. Section 7. Why deployment matters. Now let's talk about deployment. Deployment is how you move changes from sandbox to production. Bad deployment causes broken flows, missing fields, panicked users. Good deployment builds trust. Section 8. Change sets. First option, change sets. This is Salesforce's built-in deployment tool. You package fields, flows, reports, layouts, send to production, deploy. Use change sets when small teams. Simple releases, low complexity, downside, no version control, hard to roll back, manual work. Section 9, DevOps tools. Second option, DevOps tools. Examples include Copado, GearSet, AutoRabbit. They provide version control, automated testing, rollback, audit trails, CI and CD. Use them when large teams, frequent releases, compliance needs, enterprise standard. Section 10, manual deployment, third option. Manual deployment. This means building directly in production, no sandbox, no testing, no safety net. This is dangerous, never recommended. Section 11, interview level answers. If they ask, how do you move data? You say, import wizard for small jobs, data loader for large or complex jobs, and AP is for real-time integrations. Perfect. If they ask, how do you deploy changes? You say, I use change sets for small releases, DevOps tools for larger environments, and always test in sandbox first. Strong answer. Section 12, memory lock-in. Let's lock this in. Wizard equals small, loader equals large, a PI equals live, change sets equal basic, DevOps equals pro, manual equals no. Closing. Episode 5. You've just covered import tools, AP is, data safety, deployment strategy, release discipline. This is how you avoid outages. This is how you avoid blame. In the next episode, we'll focus on org architecture and access control. That's how you design systems that scale cleanly. This has been the Salesforce Admin Crash Course, Episode 5. Stay focused, stay consistent, and I'll see you in the next chapter. Episode 6, Org Architecture and Access Control. Hello and welcome back to the Salesforce Admin Crash Course. This is Episode 6. Today we're focusing on how Salesforce is structured and how access is controlled. This is core architecture. If you get this wrong, your org becomes messy. If you get it right, it scales. Let's begin. Section 1. The Architecture Triangle. Here's the big picture. 3 things shape the user experience: profiles, record types, page layouts. Each has a role. Don't mix them up. Section 2. Profiles. Profiles control what users can do. They manage object access, field access, tab visibility, app access. They answer, is this user allowed? Create, edit, delete, export. Best practice. Keep profiles simple. Use a few base profiles. Add access using permission sets. Modern Salesforce is permission set driven. In Section 3. Record types. Record types define business processes. They represent different scenarios. Example, new car inquiry, used car inquiry, fleet inquiry. Each process has different stages, fields, and automation. Use record types when processes differ. If the process is the same, don't create them. Overuse creates pain. Section 4. Page layouts. Page layouts control what users see, which fields appear, order of fields, buttons, related lists. Good layouts improve adoption. Bad layouts create frustration. Design for speed. Section 5. How they work together. Here's the chain. User leads to profile. Profile assigns record types. Record type assigns page layout. Profile, record type, layout. Memorize that. Section 6. Organization-wide defaults. Now let's talk about visibility. First layer, organization-wide defaults, also called OWD. OWD sets baseline access, private, public read-only, public read-write. Best practice. Start private, open later, never start wide. Section 7, role hierarchy. Second layer, role hierarchy. Roles control vertical visibility. Managers see down. Reps don't see up. Roles don't give sideways access, only upward. Section 8, sharing rules. Third layer, sharing rules. These create exceptions. They open access selectively, based on owner, criteria, role, groups. Example, hot leads shared with managers. Clean access, no chaos. Section 9, how visibility works together. This is critical. The order is OWD first, roles second, sharing third, start closed, open carefully, controlled access. Section 10, common architecture mistakes. Bad admins create too many profiles. Use public read. Write everywhere. Ignore permission sets. Overuse record types. These create long-term problems. Good admins, simplify, standardize, document. Section 11, interview-level answers. If they ask, how do you design access? You say, I keep profiles minimal, use permission sets for access, use record types for processes, and assign appropriate layouts. Strong answer. If they ask, how do you manage visibility? You say, using OWD as the baseline, roles for hierarchy, and sharing rules for exceptions. Perfect. Section 12, memory lock-in. Let's lock this in. Profile equals power. Record type equals process. Layout equals screen. OWD equals default. Roles equal managers. Sharing equals extra. Closing. Episode 6 you've just covered. Profiles, permission sets, record types, layouts, visibility, sharing. This is scalable design. This is future-proofing. In the next episode, we'll move into advanced data and real-time integrations. That's where performance issues and architecture meet. This has been the Salesforce Admin Crash Course. Episode 6, stay sharp, stay consistent, and I'll see you in the next chapter. Episode 7, advanced data and real-time integrations. Hello and welcome back to the Salesforce Admin Crash Course. This is episode 7. Today we're covering advanced data challenges and real-time integrations. This is where many organizations slow down without realizing why. Let's begin. Section 1. What is data skew? Here's the question. What is data skew? Data skew happens when too many records are linked to one parent, one account, thousands of contacts, hundreds of thousands of activities. That creates imbalance. Salesforce struggles to process those records. Performance drops, errors increase. Section 2. Why data skew is dangerous. When one parent record becomes too heavy, updates slow down, locks increase, flows fail, reports lag, users feel Salesforce is slow, but the cause is skew. Section 3. Ownership skew. Next concept, ownership skew. This happens when one user owns too many records, usually integration user, admin user, system account. They end up owning everything. That creates bottlenecks. Section 4. Why ownership skew matters. When one user owns most records, sharing calculations slow, automation struggles, reports degrade, locking increases, security and performance suffer. Section 5. How skew happens. Most skew is accidental. Imports use one user, integrations use one user. No assignment rules, no redistribution. Nobody notices until systems slow. Section 6. How to detect. Skew. You detect skew with reports. Group by account, group by owner. Look for huge numbers in one row. That's skew. Section 7. Fixing data. Skew to fix data skew. Split large accounts. Restructure relationships. Archive old data. Reduce unnecessary links. Spread the load. Section 8. Fixing ownership. Skew to fix ownership skew. Use assignment rules. Distribute records. Rotate ownership. Avoid single owners. Design for balance. Section 9. Platform events. Now let's talk about real-time integrations. First, platform events. Platform events are broadcasts. Salesforce publishes an event. Multiple systems listen. Everyone reacts. At the same time. Example, a lead becomes hot. Salesforce publishes hot_lead_ created. Marketing hears it. Analytics hears it. AI hears it. No polling. Section 10. Outbound messaging. Second option, outbound messaging. This is older, more direct. One-to-one communication. Salesforce sends data to one endpoint. Using SOAP, still used in legacy systems. Section 11. Platform events versus outbound messaging. Here's the difference. Platform events, one-to-many. Modern, scalable. Outbound messaging, one-to-one. Legacy, simple. Think, group message versus private message. Section 12. When to use each use platform events. When multiple systems need updates. High volume. Event-driven architecture. Use outbound messaging when one legacy system. Simple integration. SOAP-based. Section 13. Interview-level answers. If they ask, what is data skew? You say, it's when too many child records are linked to one parent, causing performance issues. If they ask about ownership skew, it's when one user owns too many records, impacting sharing and automation. Strong answers. If they ask about platform events, they're a publish-subscribe mechanism for real-time, scalable integrations. Senior answer. For Section 14, memory lock-in. Let's lock this in. Data skew equals too many to one. Ownership skew equals one owns too much. Platform events equal broadcast. Outbound messaging equals direct. Closing. Episode 7 you've just covered. Data skew, ownership skew, performance bottlenecks. Real-time integrations. Most admins never master this. You are. In the final episode, we'll cover AI, security, and enterprise readiness. That's what turns good admins into trusted consultants. This has been the Salesforce Admin Crash Course, Episode 7. Stay focused, stay consistent, and I'll see you in the next chapter. Episode 8, AI Security and Enterprise Readiness. Hello, and welcome back to the Salesforce Admin Crash Course. This is Episode 8. This is the final episode. Today we're covering AI Security, Compliance, and Enterprise Readiness. This is what separates junior admins from trusted professionals. Let's begin. Section 1. What is Einstein? Here's the question. What is Einstein in Salesforce? Einstein is Salesforce's built-in artificial intelligence layer. It analyzes data, finds patterns, makes predictions, suggests actions. It lives inside the platform, not outside, not separate, built in. Section 2. What Einstein does in practice. In real life, Einstein helps with lead and opportunity scoring, forecasting, activity insights, next best action, service automation. It acts like a digital assistant, not a decision maker. Section 3. What interviewers expect about A. Interviewers don't expect you to be a data scientist. They expect awareness. They want to hear that you know AI depends on data quality. AI needs monitoring. AI needs governance. Garbage in equals garbage out. Section 4. Using AI as an admin. Your role with AI is to prepare clean data, configure models, validate results, monitor accuracy, support adoption. You are the bridge between AI and users. Section 5. Layered security model. Now let's talk about security. Enterprise Salesforce uses layered security. Think in layers. Authentication. Who are you? Passwords. Multi-factor authentication. Single sign-on. IP restrictions. Authorization. What can you do? Profiles. Permission sets. Field security. Data visibility. What can you see? OWD. Roles. Sharing. Network security. Where can you log in from? IP whitelisting. Login hours. Trusted networks. Choose data protection. How is data protected? Encryption. Field masking. Audit trails. Shield. Section 6. Salesforce Shield. Some organizations use Salesforce Shield. It includes platform encryption, event monitoring, field audit trail. This is for banks, healthcare, regulated industries. Mentioning this sounds senior. Section 7. Compliance awareness. Many industries have rules, GDPR, financial regulation, healthcare compliance. Salesforce supports compliance, but configuration matters. Admins enable compliance, not vendors. Section 8. Security reviews. If you build apps or deep integrations, Salesforce may require a security review. They check encryption, authentication, vulnerabilities, data handling. This is more developer-focused, but good to understand. Section 9. Common security mistakes. Bad organizations often have everyone is admin, no MFA, shared logins, hard-coded passwords, public data everywhere. These are red flags. Good admins prevent them. Section 10. Interview-level answers. If they ask, how do you approach security? You say, I use layered security with strong authentication, least privilege access, controlled visibility, and data protection. Excellent answer. If they ask about AI, I focus on data quality, configuration, monitoring, and governance to ensure reliable outputs. Modern answer. Section 11. Memory lock-in. Let's lock this in. Einstein equals assistant, not boss. Security equals layers. Compliance equals configuration. Trust equals discipline. Section 12. Your professional positioning. At this point, you understand automation, data, integrations, performance, architecture, security, AI, deployment. That's the full stack of a Salesforce admin and consultant. You are prepared. Final closing. The crash course complete. You've completed the Salesforce Admin Crash Course. 8 episodes, hundreds of concepts, real-world thinking, interview-ready language. This is not memorization. This is understanding. Keep listening. Keep refining. Keep building. and opportunities will follow. This has been the Salesforce Admin Crash Course. Final episode. Stay confident, stay disciplined, and keep moving forward.